Let's say I just have some random function, random polar function rather. R is equal to a function of theta. R equals f of theta, right? But the question being asked is, what is dy over dx, right? Well, y and x, that's not the same thing as r and theta. So what do we do in this case? Well, it's actually pretty simple. We can actually rewrite dy over dx as dy over d theta over dx over d theta, right? Because the only thing we're really doing here is just dividing d theta on both the top and the bottom. That doesn't really change anything. But what's dy over d theta? If we want to find out what this numerator is, we're going to need to know what is y in terms of theta, because otherwise we wouldn't be able to find the derivative. You know from our basics that y is just r times sine of theta. But we still don't have y in terms of theta because of this r. But r is just equal to a function of theta. So y ends up just being a function of theta. So how do we take this derivative? What is dy over d theta then? If y is just function of theta times sine of theta, well, we can just look at each of these two terms as different functions of theta, right? We can look at this term as a function of theta, and then this term as a function of theta. And then we can just take the product rule and apply it to dy over d theta. If you don't remember what the product rule is, remember, if we just take a derivative of u of x times v of x, right? Assume both of these are functions of x divided by x, we can just apply this formula and we can find the derivative of the product. So let's apply that here. So what's the derivative of f of theta? Well, we'll just call that f prime of theta for now, right? Obviously, this is gonna, change depending on what kind of question you're doing. And then we just do sine of theta plus f of theta, and now derivative of sine of theta with respect to theta, which would obviously just be cosine theta. That's just a standard derivative. Let's try that with x now, which again is just two functions of theta multiplied with each other. Remember, you can just think of this as u and this is v, and we can just take a derivative as if these are just two functions of theta. Now in this case, what we would have to do is essentially take a derivative of f of theta. So that would be f prime of theta. And then cosine of theta this time. Then we have to add f of theta. But in this case, remember, we're taking a derivative of cosine of theta, right? What's the derivative of cosine theta? That's negative sine theta. And obviously this positive and this negative is just going to turn into a negative, so it would really be f prime of theta cosine theta minus f of theta sine theta. I just wrote the negative here just so you can see the relationship between the derivatives a little bit more clearly. So hopefully you can see a really obvious thing. We can just divide both of these terms and we can get our final answer. We would get this numerator right here, and then we would divide it by dx over d theta, which is going to be our denominator. And that's it. We have our derivative. It is just this very long equation. Now, something you can totally do is just memorize this equation, because, of course, you can memorize it and it will always work. It's just f prime theta sine theta plus f theta cosine theta divided by this bottom term. I don't really recommend doing that, because this part right here, y equals r times sine theta, x equals r cosine theta, this, in my opinion, my personal opinion, is much easier to remember than this long equation here. So as long as you remember that y you can write y as a function of theta, x as a function of theta, divide the two, it's going to be a lot easier than memorizing this giant equation.